All right, hey guys, we're gonna do our first real calculus lesson here, finding limits graphically and numerically. So we're gonna solve some limit problems using a table and then looking at a graph as well. All right, so um, a normal limit problem, your first line of defense is just to simply take this number that you're approaching. So the way you would read this is the limit as x approaches -3, and you just plug it in for x. And if you get an answer when you plug it in, that's it. That's your answer. It's the problems where you don't get an answer, where you get something like this, where you run into a problem. So let's see what happens when we plug this in. We end up with the square root of -3 plus 4 minus 1 over -3 plus 3. All right, and I'm not going to put an equal sign because that would be incorrect math. So I'm just going to draw an arrow. And this is 1, and the square root of 1 is 1, minus 1, so that's a 0. And then -3 plus 3 is 0. Anytime you get 0 over 0, that's a big problem. We call this an indeterminate form. And that word indeterminate means we cannot determine what the answer is from what we just did. All right. So what this means to you, what it should tell you in your head, is you have more work to do. All right. Another thing that could go through your head is, oh no, because 0 over 0 means that we can't solve it just by plugging the number in. All right, so the way we're going to solve this one, we're going to learn how to do this one without a calculator algebraically on another lesson. But today we are going to use a table to do this, and then we'll graph it as well so we can look at it on the graph. So what we have here is we've put x equals -3 kind of in the middle. It's hidden because if you plug in -3, you see what happens there. So we're not actually going to put that in our table, but we're going to pick numbers that get really, really close to -3 and see how we're coming from the left side of -3. And then we're also going to do the same thing coming from the right side of -3. All right, and what we're going to do is we're going to find what the y values are, the f of x values. Okay, and we're going to use a calculator to do this because we're dealing with decimals. So I'm going to show you what I think is the most efficient way to do it. You're going to open up a graph page on your calculator. So let me start over here. So you're just going to add a graph, and then I'm going to hit Control divided by, and then we're just going to type this in. So we have the square root of x plus 4 minus 1. And then on the bottom, we have x plus 3. All right, I'm just going to hit enter. There's our graph. We'll sketch that in a second. Okay, now if you just go to the table, you hit Control T, you're not going to be able, you can't plug numbers in here. Now there is a way to change the settings on the table so you are allowed to plug in, but I actually don't think that's the most efficient method. So I'm not going to do it that way. So I'm just going to hit Control T again, get rid of that table. So what I'm going to do is we're just going to trace the graph. So menu 5, 1. Okay, and you can hit the left and right arrows up here and trace, but again, you'll notice that it's telling you what numbers to plug in. It's not letting you plug in your own numbers. Okay, but when you're tracing, you can just type in whatever number you want. So for instance, the first one in our table is -3.1. See, it shows up right there on your screen, and then you hit enter, and it'll go there, and there's your y value, 0.513. So we're going to write that down right here, 0.513. All right, and then you just type in the next number, -3.01. Enter. 0.501. Right, and then our next one is -3.001. 0.500. Okay, notice I'm rounding my decimals to 3 decimal places. That is a requirement for the AP exam. If you have zeros on the end here, you could leave those off. You could just write 0.5. I always put the 3 decimals though. AP exam says we have to be accurate to 3 decimal places. So even if it's a 0, I'm going to write it there. All right, let's plug in the other ones on the other side. So -2.9. I'm going to start on the very right and kind of work my way back to the middle. All right, 0.488. That was this one right here. -2.99. 0.499. And -2.999. And that's point. See that 8 right there is going to round this up, 500. All right, and so what we are seeing is that f of x is approaching, from the left side, it looks like it's approaching 0.5, 1/2. And from the right side, you see how it's approaching the same value? We're getting the same number in the middle. So even though when we plugged in -3, we got 0 over 0, we're saying the function, the limit of the function is approaching 1/2. All right, so what does that look like on our graph? You can see the graph here, and you can't really tell anything's awry. All right, and here's -3 over here. So let's type in -3. And see, undefined right there, it shows you a little asymptote. Now, it's not an asymptote. The calculator is just programmed that way. But there is something going on there that it's undefined. All right, whereas if we type in -2 point, I think my trace went away, -2.99999, you can see that we have a point there. All right, so here's what's happening. We're going to sketch this in. All right, so we're over here at -3. And we're positing, so +1, we're positing that this point is at 1/2 right there. Okay, and so something's happening there, and I'll just go ahead and tell you, I guess. What's happening there is we're getting a hole. So whenever you have something like this, a 0 over 0, that means there's a hole in the graph right there. So that's what we're going to graph on here. We're going to put a hole, and then it goes to the left a little bit from there. See how it kind of curls up, but it stops right there. It doesn't go any further. The reason for that is we do have a square root in here. So anything to the left of -4 is undefined, because that would give us a negative number inside the square root, and you're not allowed to have a negative number inside the square root. So it's going to have a point here at -4. It's going to kind of curl down, and then it just it keeps going down, but it eventually will approach 0 if we kept going that way. All right, so that's looking at it graphically. And if I just gave you the graph, let's say we didn't do the table at all, and I just gave you the graph, you would still be able to solve this limit. Even though it's 0 over 0, you would still be able to say that this limit, I guess we can say that this answer over here, the limit as x approaches -3 of the square root of x plus 4 minus 1 divided by x plus 3 is equal to 1/2. That is the answer to this problem. Okay, and you can see that graphically here, because you can see that as we approach from the left and the right, I said them backwards, but you get the idea. As we approach from the left and the right, we're approaching this open circle right here, and it's approaching the same value from the left and the right, and the value it's approaching is 1/2. So that's how you do it graphically. You look at what the function is approaching. It does not matter if the function is defined at that point. All that matters is that you're approaching the same value from the left and the right. All right, now that took a little bit of time, and I don't want my video to be 2 hours long, so I want y'all to try these two on your own using your calculator. Maybe just this one, on your own using your calculator, and then unpause, and it'll be filled in for you. All right, one thing I want to do before I fill in the rest of the table for you is this one didn't fill in the x values for us. So see that we are doing a limit as x approaches 0 this time. So that would be what's in the middle. It's not going to be in our table, because again, if we plug in 0 here, we would get sine of 0 divided by 0. And sine of 0 is 0 over 0. Oh no! All right, so we have more work to do, and we're going to do, once again, the table. So you want to pick numbers on the left side to get closer and closer and closer to 0, and numbers on the right side. So left side of 0, we're going to have negative numbers. Negative, and I'm going to start with 0.1, and then negative 0.01, and then negative 0.001. Then on the right side, we're going to have positive 0.1, positive 0.01, and positive 0.001. So those are the x values you want to work with. Come back after you've plugged those in and see how you did. All right, so there's our result. You should see that the f of x values are approaching 4 from the left and the right, and so that limit is equal to 4. And visually, you can see that the function approaches, again, it's an open circle there. Anytime you get a 0 over 0, that's an open circle at that point, but it is still approaching the same value from the left and the right. All right, now we're going to look at just more graphically. So we are going to sketch a graph, and we are going to find the limits, not doing a table. All right, so we practiced doing piecewise functions in our pre-cal review, so we're going to revisit that here. So this is a little different, though. There's no inequalities, not less than or greater than. It's just this is true when x is not equal to 2, and then it's this point when x is equal to 2. And then we want to find the limit as x approaches 2. So that's obviously the point of interest in this problem. All right, so I'm going to focus on the top part. So basically, I can plug in any number I want for x except 2. Not allowed to plug in 2. All right, so let's plug in a couple numbers left of 2, like 0. So if I plug in 0, I get 1. Let's plug in 1. So 1 squared is 1, plus 1 is 2, so 1, 2. And then let's plug in, so we're not going to plug in 2. Let's plug in 3. I think 3 is going to get, so 3 squared is 9, plus 1 is 10. All right, that's going to go kind of way up there, so I'm not going to graph that. Maybe let's go left a little bit. Negative 1 squared is 1, plus 1 is 2. All right, it's a parabola, so you might even have known what this looked like already. It's the parent function shifted up 1 unit. All right, so it's going to look like this and like this, but then something happens at 2. Okay, that's where, if x is not allowed to be 2, that's where our open circle is going to be. So if I were to plug in 2, 2 squared is 4, plus 1 is 5. So 2, 5 would be an open circle. And my function would pass right through that open circle like that. All right, now this piecewise function has redefined that point. So that point is missing from the parabola because x is not allowed to be 2, and it is moved here. So when x is equal to 2, our point is at 3. So 2, 3, which is right there. All right, so in Algebra 2 or pre-cal, I could have asked you this question. What is f of 2? Find f of 2. And you would have said f of 2 is equal to 3. That would be the answer. Calculus, I'm asking you, what is the limit as x approaches 2 of f of x? This point doesn't matter for this question. Okay, all you care about for a limit is what is the function approaching from the left and the right. So from the left, the function is approaching that open circle. From the right, the function is approaching that open circle. That open circle is the answer to this limit problem. The answer to this is 5. The limit and the actual value of the function do not have to agree. Okay, the limit doesn't care what the actual function value is. The limit only cares about what the function is approaching as the x value approaches that number. All right, this one is a little bit tougher of a question. You haven't seen a function like this very much, so we're going to make a table. All right, so I'm going to have us make a table here, x and f of x, which is equal to the absolute value of x plus 3 divided by x plus 3. All right, so x equals -3 is our point of interest. Now, we are not doing a table like we did up here, so we're not going to do one like that. I'm just making a table so we can create a graph on the right. Okay, so I'm just going to pick a couple numbers to the left of -3. So like -5 and -4. And then we don't need -3 because if I plug in -3, -3 plus 3 divided by -3 plus 3, that is 0 over 0. Oh no! All right, so we have more work to do. We're going to look at the graph. So I'm not going to put -3 in my table, but I will do -2 and -1. All right, so if I plug in -5, I get -5 plus 3 absolute value over -5 plus 3. So -5 plus 3 is -2, but the absolute value turns it into +2. No absolute value down here, so it stays -2. Simplify, that's -1. All right, absolute value of -4 plus 3 divided by -4 plus 3. -4 plus 3 is -1. Absolute value turns it into +1 divided by -1. So that simplifies to -1. And in fact, if we kept going left, -6, -7, -8, we would get the same pattern. It would be 3 over -3, 4 over -4, 5 over -5. And all of those would simplify down to -1. So everything going to the left of -3 is going to be a -1. All right, pattern's going to change a bit when we get to the right. So this is going to be -2 plus 3, absolute value, over -2 plus 3. -2 plus 3 is 1. Absolute value keeps it 1. -2 plus 3 is 1. So that simplifies to +1. Absolute value, -1 plus 3, divided by -1 plus 3. -1 plus 3 is 2. Absolute value of 2 is 2, divided by 2. That's 1. So every number going to the right of -3 is going to result in +1. All right, so -3 is our point of interest. And if I plug in -3, I get this 0 over 0. That we know that means open circle there. So, and all my answers are either going to be a y value of +1 or a y value of -1. Okay, so I'm going to start with an open circle at -3, +1, and every number going to the right is +1. So I'm going to go to the right like that. And then I'm going to put an open circle at -3, -1, and every number going to the left from there is equal to -1. So that's what this graph looks like. Familiarize yourself with this graph. Anytime you see something that looks like this is what the graph is going to look like. All right, and this has an interesting property. All right, so now that we have a graph, we can evaluate our limits. So remember, we're always looking for the limit to approach the same value from the left and the right. So if we're looking at -3, that's our point of interest. And so if I'm coming from the left, there is no graph up here on the left. So the graph's down here. So as I'm approaching -3 from the left, I'm approaching -1. But there's no graph on the right down here. So if I'm coming from the right, I'm up here on this side. And as I'm approaching -3 from the right, I'm approaching +1. So this function approaches different values from the left and the right. So this is something we haven't encountered yet. This is our first one. So this is an answer for a lot of limit problems. The limit as x approaches -3 of the absolute value of x plus 3 divided by x plus 3 does not exist. And a lot of times we'll just write D and E for that. Okay, and so the reason that the limit doesn't exist is because it approaches different values from the left and the right. So you don't always have to write this, but we're going to put it in our notes. And so we'll put because absolute value of x plus 3 over 3 approaches different values from the left and right as x approaches -3. All right, that is it for that one. All right, so last thing we're going to do is we're given this very complicated looking graph. These are very popular with limit problems because you can ask a lot of questions about different spots and have a lot of different things going on. All right, so first question is not a limit problem. It's just asking what is f of 0. So anytime you're asked where a function is defined, you just go to that graph and look for the closed circle where the x is equal to 0 and our answer is -4. All right, f of 1. So you go to x equals 1, you look for a y value where there's a closed circle and there isn't one. All right, there is an open circle there, but that is not defined. So we don't say does not exist for just a regular function. We would call this undefined. Does not exist is pretty much specific to a limit question only. All right, next one. All right, so the limit as x approaches 0 of f of x. So we're looking at x equals 0 right here. And again, when we're doing a limit problem, we're looking at where is the function approaching from the left and the right. So from the left, this function is approaching not quite 1, but whatever point that is. And then from the right, this function is approaching -4. So it's definitely approaching different values from the left and the right, which means that this limit does not exist. And it says If it does, find it. If not, explain why. So it does not exist because f of x approaches different values from the left and right as x approaches 0. All right, limit as x approaches 1 of f of x. All right, so now we're looking at x equals 1. And this function is approaching this open circle from the left. This function is approaching this open circle from the right. So even though it's an open circle, the function is approaching the same value from the left and the right. And that value is negative 1. So the answer to that one's negative 1. All right. I usually try to circle these. X is approaching 0. Here, x is approaching 1. So our next problem, limit as x approaches negative 3 of f of x. So at x equals negative 3, there is an asymptote there. Okay, so as x approaches negative 3 from the left, we are going to positive infinity. And as x approaches negative 3 from the right, we are going to negative infinity. So there's two possible answers here. Well, there's one possible answer. The answer to this is does not exist. There's two possible explanations for why this does not exist. Okay, we could go with the same explanation we did for part C. The graph f of x, the function is approaching different values from the left and the right. But also, even if they were approaching the same value, let's pretend that this graph was going up like this, and they were both approaching positive infinity. That would still be does not exist. If a graph does not approach a real number value, then the limit does not exist. Okay, now, if that were the case, we could say this limit equals infinity. That's an acceptable answer. College Board will accept that answer, and I actually prefer to write that as an answer instead of does not exist. Okay, so just keep that in mind. We'll encounter this a little more. I don't want to go too far into it, but just letting you know, if the function approaches infinity, that is still a version of does not exist. But since these approach different infinities, it is all the way does not exist because it is approaching different values from the left and the right. All right, next one, the limit as x approaches 5 of f of x. All right, so I just went on this whole diatribe about this, and I didn't realize we were going to have an example. So this is another asymptote here, and now the function is approaching positive infinity from the left, and the function is approaching positive infinity from the right. So they are approaching the same value from the left and the right, but I just use that word value, and that's not really true. Infinity is not a value. Infinity is unbounded behavior. It's just continuing on forever. So if this is the case and they are approaching the same infinity, then you can write this limit is equal to infinity, and you're done. That's all you have to put. Okay, AP exam accepts that. I accept that. I prefer that. It gives us more information. The other way that you can write this, and the reason I'm telling you this is because you could see this as an answer on a multiple choice question. So they could give you this exact problem. This answer could not be there at all. They wouldn't put it. And they would put this answer instead. The limit as x approaches 5 of f of x equals does not exist. Oh. Sorry about that. Let's get this erased here. All right, does not exist. All right, so that is also a correct answer. In our notes here, they say if we write does not exist, we have to explain. So it would not be the same explanation, right? Because it's not approaching different values from the left and the right. It's approaching the same, again, not a value, but the same general direction. And so what we would have to explain here is because f of x increases without bound. As x approaches 5. Okay, so without bound means it's going to infinity. It's not bounded by a value. Okay, so that's another version of does not exist. I'm going to put in parentheses here. Anytime you have unbounded behavior, your limit does not exist. Now, writing that this equals infinity, that tells you that already. That tells you it's unbounded because infinity is unbounded. And we know that that means it does not exist as well. Okay, but this is a very concise way to write your answer, so you don't have to write this entire sentence out here. So I'm always going to recommend saying that this limit equals infinity rather than equals does not exist, because we won't have to explain further after. All right, sorry that it was pausing in and out all the time. I've had stuff going on here at the school, so hopefully it wasn't too confusing and disjointed for you. I will see you on the next video.